Hi, this is Will from .text. Today, we're going to talk about solving the hardest problem in computer science, or at least one of them. I hope you don't find that the thumbnail was too much of a clickbait, but there's this famous quote by two people actually that says there are only two hard things in computer science: cache invalidation and naming things. And today, we're going to solve the second problem, which is naming things. This quote, interestingly enough, is attributed to Phil Carlton, but the only place that reference can be found is on Martin Fowler's blog. So we have a double citation here. But we're going to talk real quickly about this problem, then dive straight into the code, give you a sense of how to build this thing, and then finally end the video with a little demo of it actually running. So what our goal here is we would like to take, and this is a common problem I think we all have, a bunch of files that are very poorly named and confusing and rename them into better files. As you can see, our initial files have terrible names like scratch, untitled 1. I'm sure most of you have things like final revision, last draft I swear. Very common problem. And what we get in the output is really nice. You notice these all have dates on them. They are all sorted by different categories of things, and then they have a little bit of information about what they're actually about. You can see there's this lunch notes, and you'll see in the code in a bit that there actually is, in fact, a list of where to eat for lunch in that document. So this is a tool we're going to build. It actually is useful. It's also a great demonstration of when and why you would want to use local open models. So without further ado, let's dive straight into the code and see how this program can be built. And then in the end, we'll take a look at how it actually works. Okay, let's take a look at the code and sort of understand how we're going to actually build out our file renaming tool. This tool is ultimately fairly simple. It's really just a basic command line interface and some straightforward functions we'll build out to read the metadata from the file and sort of get some information that we'll need for the model to rename them correctly. And then some sort of basic LLM stuff that is surprisingly straightforward, especially because we're going to be using outlines to use our structure. So let's take a look at what we have here. We're starting with a model name, and this is the model we'll be using for this. It's easy to change out if you want, but I choose Microsoft Phi 3 Medium 4K Instruct. It's a good size model, has great performance in the past, and there's always new models coming out, but for now, this one is one of the ones I like to work with. It's worth pointing out here that this local open model is essential for this task. We are building a file renaming tool which will need to have access to file metadata and ideally file contents in order to correctly rename the files on my computer. They're my files, they're private information potentially. I personally do not want to send that over the wire to some third-party provider. As much as I may want to trust OpenAI or Anthropic, I still feel much more comfortable that all of my truly personal data remains on my machine. I also like that we're using an open model and open tools because I can always know that what I'm working with has been sort of vetted by other people and is trustworthy. I don't necessarily know that other local model providers are 100% trustworthy. So personally, I'm a big fan of the open local approach. But in general, what we really want is local models to know that we're not sending stuff to a third-party provider. I have some basic categories here. That's because I would like my files to be categorized by sort of general topics. So this is just sort of some demo data I put together. So basically I think there's data files, there's going to be notes, there's going to be sort of meeting minutes, and there's going to be various like corporate memos. And that's sort of what I'm thinking of right now. And that's what my sort of demo data reflects. The most important part is our structure. Structure generation is essential to this problem because we want consistent file naming. This is really the magic of the whole thing, and this is what makes everything so simple as far as our prompting and generating data. So what I want is a file that looks like this. I want to have this date format, so all my files will naturally be sorted by the date that they happened. I want to have this category as the next thing, and then I want a brief description, very brief, of what the file's actually about. So this is nice because if you just sort by the natural naming of the files, you'll get this nicely ordered data that is very easy to understand, very easy to walk through. You know exactly what date it happened on, what its general topic was, and then a little bit more details of what's in the file without having to peek inside. The structure we use for this is fairly straightforward. As you can see, we're going to take 4 digits, 2 more digits, 2 more digits. This is going to give us our date format. And then we're going to have, it has to have one of these categories. So we're forcing the model to answer with one of those categories. And then we're going to give it between 5 and 150 characters to describe it using just letters and an underscore. So we don't get any strange characters or anything that will be difficult for our operating system potentially to understand. And we get a very straightforward output from this. We're just going to use the file extension from the original file, so we don't have to worry about the file extension and keeping track of that. So this is our basic logic. If you wanted something more thorough, you could easily extend this to have a longer file name if you wanted, or you could change the date format, however you want. But I like this one because it means my files will sort in a fairly natural and easy to navigate order. Now let's take a look at our prompt. You notice that we're passing in, we're going to use a tokenizer here because we're going to use the apply chat template from Hugging Face's Transformers, which I always recommend using. It just means you don't have to worry about the underlying instruct format for the model. But the most important thing is the file metadata. In a way, this is actually similar to a RAG or retrieval augmented generation problem because we need to provide additional data to this prompt in order so that it can do its job as well as we want it to, the best it can. So our prompt is pretty straightforward. We have the file categories we're mentioning here, and we're going to do two pieces of file metadata right now, and I'll talk about this more in a second. We actually can add a lot more if we want later, but for this demo, I just cared about these two things. So we actually are going to read the actual files on our machine, and we're going to take a peek at the content that's in them. So, it's like the head file, head command in Unix. So we're going to take this head content. We don't use the whole file because it may be too large for our context. We're going to take up to 1,000 characters for this demo, I believe. It is configurable through the command line arguments. And we're also going to add a creation time. This is because we want the model, ideally, to read the file and find a date reference there so we can put a date. But if there's no date reference there, we kind of force the model to hallucinate a date. So what we're going to do is we're going to put in the creation time as a backup for in case it doesn't have the information. And this is also a good example of how to think about constructing your prompts and what kind of data you want to be in that prompt. In this case, I only really care about making sure it gets the date correct. But if I don't give it enough information to do that, we can't really expect that to happen. And I give it some instructions on what I want. I give it examples of files, and then we just sort of build that prompt. Let's take a real quick look at actually the file processing logic behind this. It's not really that important from an LLM standpoint, but this is where our data comes from. So this is a pretty straightforward file. We have a couple things to list the files and get pairs of file names with their metadata, but this is really doing the bulk of the work here. This is just going to get the file metadata, and it gets a whole bunch of things. It's going to get our file name, its extension, it's going to get the size of the file, creation time, creation date, modification time, modification date, head content, which we're going to read a little bit of file as I mentioned, and this sort of file type by extension. So we're not actually using all of these, but I actually had AI write this function for me, so I didn't have to worry about it. And we could definitely use these in future iterations. So it's good that we're collecting all this extra metadata so that we can go ahead and modify that. Okay, let's go back into how this is actually going to run. So this is it. This is the whole logic of our file naming system. We are going to create a generator with outlines. We're going to use regex, and of course we're using this regex we defined up here, right? This is the structure we want our output to always consistently be in, and this is how we want our files to be renamed so they're nice and easy to understand. And this is really all it does. So we create a generator, we apply the prompt with the file content that we're going to pull out, and then we get a new name. And we return the new name, and then we also, when we actually do the renaming of that, we make sure to keep track of the file extension, and we only rename the core name of the file. But most of the rest of the logic here is just sort of basic reading files, writing files, and sort of making sure everything is running smoothly. And then when we actually run main, we just got to load our model and have the tokenizer, and then we just run the rest of this. So that is the basic logic of our file processor. So pretty straightforward. And again, the thing that's really doing most of the magic here is the structured generation, which guarantees that our file names will follow a format that is consistent and useful for us. So there's that. Let's go ahead and take a look at the actual project that we've built in action. We can see it name some poorly named files and hopefully get some good results. Okay, let's take a look at our tool in action. We'll start out by listing the files we have. As you see, we've got a bunch of very poorly named files that we would like to rename. We can take a look inside. This one has some JSON data. If you look in this notes file, it's just some ideas for lunch that we had. And then we can look in this last file, also poorly named, untitled 1, and we see we have this whole like marketing brainstorm stuff. So now all we have to do is just run our little program that we wrote and give it the demo directory so it knows which directory to use. We're going to load the model real quick. And now it's generating new names. And as you see, there it goes. And it's generating names that follow the structure we want. It's pulling out the dates from these files, which is pretty cool. And if you look carefully, it's actually getting the best date it can. If it doesn't have a date, it'll pull it from the metadata. And now there we go. We have these well-named files that are actually all rewritten and working, and we're all set. So there's our file renamer in action. We don't have to think about what to name our files anymore. We're all set to just go and have all of our files nicely organized.